Welcome back to another episode of Learning Integration. We'll be focusing on integration by substitution using e's or exponentials with e to the power of x. Here's the rules for e to the power of x when finding the integral. You've got fx equals e to the power of x. When you find the integral, you have e to the power of x plus c. Basically, when it's just e to the power of x, it doesn't change. But when you have e to the power of kx, k resembles a number like 7, 10, whatnot. So if you have e to the power of a number times x, you get e to the power of the number times x divided by the number plus c. Just like the power rule, where when you find an integral, you add 1 to the power and then you divide by the new power. E to the x is a bit similar. We're dividing by the power, but we don't change the top, and that's because that's how e to the x works. Just like here, we don't change it. Here it doesn't change. You just divide by k, because if we were to find the integral and if we were to derive it, we would bring the k down and they would cancel out. Okay, so those are the rules. Let's get on to some examples. Example 1. Fx equals 2x multiplied by e to the power of x squared plus 1. Okay. If we find the integral of either side, capital Fx, integral 2x e to the power of x squared plus 1 dx. Now what's next? If you watch my other video on substitution, you should know what's next, but if you don't, basically we're going to we have two functions, they're both multiplied together. One of the functions, inside it, think of it this way, one of the functions, which let's say e to the power of whatever, inside the brackets, if you try and derive that, would you get something similar to this? The answer is yes. If you don't know, you will find out. But let's say we derive this. We'll do the steps, which is subbing it. And that's why this is called integration by substitution, because there's a lot of substituting. So we'll sub u 4x squared plus 1. Now what will that make the original equation look like? That'll make it, if we sub x squared plus 1 for u, we'll get something that looks like 2x e to the power of u dx. Okay? But for now, let's derive it. Du over dx equals 2x, because you derive x squared, you get 2x, you derive 1, you get 0. So it's 2x. Now, here we have a dx. Here we have a dx. We can rearrange this to make all of this, or part of this, equal dx. So we're going to multiply dx up to 2x, and we're going to divide 2x down. And it will look like this. If you're paying attention, it will look like this. We have dx on its own. There's dx on its own up here. We can sub du over 2x for dx. Okay. The power of u multiplied by not dx but du over 2x. Some people think just because there's an integrand over here and a dx, you don't touch these. You don't really touch that, you just get rid of it at a certain point. But you can touch this. This is multiplied on. the dx. But anyway, just remember that if you ever got confused. Okay, now, I hope I didn't just confuse you, don't hate me. But, we have dx, and now we subbed in du over 2x for that. Now, I don't know if you can see it, but we have a 2x multiplied and a 2x divided by, or divided by 2x. Essentially, we have 2x multiplied by e to the power of u to du over 2x. So we can cancel the 2's and we can cancel the x's, because we're dividing 2x by 2x, essentially. Therefore, all we're left with is e to the power of u du. Now, here comes the easy part. What's the derivative of e to the power of u? Just like when we had e to the power, the integral, just like we had e to the power of x on the rules I showed you, when you find the integral, you just have e to the power of u plus c. So I showed you earlier. E to the power of x, when you anti-differentiate, you get e to the power of x plus c. In this case, we have u, so e to the power of u. When you find the integral, you get e to the power of u plus c. Now what we need to do is sub u back in. So technically you should write sub in x squared plus 1. Next step then would be to sub in x squared plus 1 back in. And that there is the integral of 2x multiplied by e to the power of x squared plus 1. Okay, do another example. Example 2, we're going to make this fx equals e to the power of x sine e to the power of 2x. Okay. Oh, sorry, that won't work. E to the power of 2x multiplied by sine e to the power of 2x. Okay. So the idea is we have a function multiplied by another function. Inside one of the functions, if we derive it, can we get something that looks similar to the first function? And the answer is yes. In this case, they look identical, but yes. So we'll find the integral of one side, and we'll find the integral of the other side. Okay, now this comes to subbing part, or the substitution part. We'll sub u for e to the power of 2x. Okay. Now, what do we get? Well, what do we get here? Well, we get you could essentially, well, we've got to derive it, obviously. E to the power of 2x, when you derive it, it's 2e to the power of 2x. And if we rearrange it, du over 2e2x equals dx. So we sub in this for dx. It's very hot where I am, it's hard to concentrate, but I'm not giving you false information, don't worry. So we'll sub it in. We've got fx equals integrand e to the power of 2x sine u du over 2e to the power of 2x. Now, we've got an e to the power of 2x and a 2e to the power of 2x. So we can cancel these out. And what are we left with then? We're left with a half multiplied by du. We can bring the half out because multiplication by a constant. And we're left with sine u du. Some people might say, you know, we made u equal to e to the power of 2x, therefore we should have made this u, but because I'm eliminating it, I didn't make it a u, because we're eliminating it. Therefore, we keep the half, and the integral of sine u with respect to u is going to be negative cos u plus c. Okay, now we got to expand the half into the brackets. A half multiplied by negative cos is negative cos over 2 plus half of c, because we're expanding the half into both of them. Now, because I like to do things like I don't like having a constant like looking like that, because it's a constant multiplied by a constant. I like to just keep it one number. But because we don't know what c is, we can sub a letter in. So I like to use h a lot. And let's say h equals half of c. Therefore, instead of writing half of c, we could just write h. So the integral will be negative cos, I'll sub in u. We said u was e to the power of 2x over 2 plus h. And there you go. There is your integral for e to the power of 2x multiplied by sine e to the power of 2x. Thanks for watching. I hope you learned something.